Good morning, friends. Today we are going to study the second topic of the plant tissue series. In the previous tissue or previous topic, I taught you that what is tissue, what is the branch of biology in which we are studying tissue, what is the difference between tissue, histology and anatomy, why tissues are formed, and what are the advantages the living beings got after the formation of tissue. Now, as biology is bifurcated into two, one is plant section and other is animal section. That means botany and zoology section. So, in plant section, there are two types of tissue. So, in this topic, I will cover only the meristematic tissue. In the next series, that is plant tissue series topic 3, I will teach you the permanent tissue because teaching both the topic will make the video very long. So I think a little bit I can make the video separately. First thing is meristematic tissue. Dear children, first we have to think that how we can recognize meristematic tissue. पहले हम ये समझेंगे कि मेरिस्टेमेटिक टिश्यू को हम कैसे पहचान पाएंगे because there are two types of tissue, meristematic tissue and permanent tissue. Only two types of tissues are there. Okay, meristematic tissue are further classified into many types on the basis of origin, on the basis of formation, and permanent tissue are also classified on the basis of their formation and on the basis of their occurrence and the functions also. Here, meristematic tissue can be recognized with their property. First, we should remember that meristematic tissues are newer tissues. These are the point to be learned, or you can recognize. You can recognize the tissue that how we can say this is meristematic. First, they are newer cells, or they are made up of newer cells. We can write newer tissue. Newer tissue found in growing areas of plant. Now, nothing is diplomatic here. If you start to think that what are the growing areas of the plant, generally plant are growing by the tip, by the lateral side, or some by the nodal areas. So three areas are the growing point. What I told, first is the tip where the apical meristems will form. If you have heard the sound, if you have heard the word previously, let's recapitulate. Tip. Tip, that means apical meristematic tissue, there will be found. Now in circumferral area or peripheral area of the stem, their lateral meristematic tissues are found. Now in the nodal areas, below the nodes, upside the nodes, between the two nodes, that means in internode, intercalaries will be found. So growing areas. Once there was a question that if we insert a nail at 1 meter height of a stem, after 3 or 4 years, what will be the position of that nail? Here the point is very clear. If we inserted a nail at the height of 1 meter in any stem, the stem will grow in next 4-5 years. But the position of that nail will not change. Why it will not change? Because plant is not growing by that area. Plant is growing by the tip or by the circumference. If the nail will come out, okay, lateral displacement can be there in the nail, but in vertical displacement will not be there. So newer tissues found in growing areas of the plant, it is the first characteristics of the meristematic tissue. Second is the cells are compactly arranged without leaving any space or what that space should be called? Intercellular space. The point must be understood. The cells are, that means the cells of the meristematic tissues are compactly arranged. They are arranged so closer that there will be no space among them. The spaces among them, if present, in permanent tissue, you will see that intercellular spaces will be there. In few permanent tissue, not all. So, if they are compactly arranged, they don't leave any space, and that is called intercellular space. The space is called. The third thing is the cell walls of the cells are thin, although cellulosic. Thin, although cellulosic. That means there is no confusion that the cell walls present in cell walls of the plant cells are made up of cellulose. So there is no confusion. They are made up of cellulose, but the thin, the word thin represents that there is no deposition of any metabolic waste or any extra deposition like suberin, lignin, pectin. So these all things will not be deposited. The cell walls of the cells are thin. Now the next characteristic point is the cytoplasm of the cells are dense and metabolically very active. Metabolically very active. Metabolically very active, as you know that actually the the cells of the meristematic tissues are found in the growing region. So plant need more energy, more life processes like nutrition, respiration, etc. More life processes to do at that place. So the cytoplasm of the cells are dense and metabolically very active. Now, for regarding the vacuole, you should learn vacuoles are absent. Vacuoles are absent. For the nucleus, regarding nucleus, you can learn the nucleus are central and more prominent. More prominent. So, how many points I gave you? 1, 2, 3, 4, 5 and 6. For the meristematic tissue, once again, try to understand. If you have any confusion, you can ask. I will answer. First, these are newer tissue. The technical point should be noted down. These are the newer tissues found in growing areas of the plant. Second, cells are compactly arranged without leaving any intercellular space. The cell walls are thin, almost cellulosic. Cytoplasm of the cells are dense. Cytoplasm are dense and metabolically very active, so that the nutrition process, the photosynthetic process, the respiration process will remain faster there. What vacuoles are absent, nucleus are central and more prominent. These 5-6 are the characteristics of the meristematic tissue. If you start thinking about the meristematic tissue, you can imagine how the cells should be active at the places where growth is going on. So these all things are very important for the growth of the plant. So meristematic tissues are mainly responsible for growth of the plant. This thing must be noted. Now secondly, we should learn the types of the meristematic tissue. These were the characteristics of the meristematic tissue. Now types. Broadly, meristematic tissues can be of two types. First, promeristem or promeristematic tissue, and second is primary meristematic tissue or meristems we can write. Promeristems and primary meristems. Now, what are the differences? Promeristems are the initial tissues formed from the embryo. You know, this is the life process. First zygote is formed, then cleavage will undergo, and then after cleavage, the zygote will convert into embryo. So, from the embryo, if tissues are formed, they are called promeristems. That means we can write the subtitle to learn the word. It is very easy in biology, it is very easy to learn a word by the subheading or subtitle. So I'm always giving a subtitle. How you can learn, how you can recognize this word. Promeristems. They are formed of formed from embryo. And primary meristems, they are formed from promeristems. So you can here learn that this is actually the latter stage of the life. Initially, embryo will form promeristem. While growing older, by the age, the promeristems will change into primary meristems. You must recapitulate this again and again that all the meristematic tissues are by age, by passing age, they are got converted into permanent, and after getting permanently differentiation, they will be dead. So most of the tissues in the plant are dead. Primary meristematic tissues can be of three types on the basis of occurrence. You must remember, on the basis of occurrence. First type is apical meristems, second type is lateral meristems, and third type is intercalary meristems. For a student of class 9, they must remember the occurrence, the structure, and the function. Structure, what I taught you about the meristematic tissue, that is those are the common structures found in all kind of meristematic tissue. So apical, lateral, intercalary, that those are the common structures. Now, why these three different names are given if they are common in structure? They are named differently as per their occurrence. That's why I wrote there on the basis of occurrence. Now, apical meristematic tissue. Now, where they are found? Occurrence. As the name represents, you can learn apex. Apex means the tip area, or apex is just similar to apical. So, these are found at tip of shoot and root. Shoot and root. I am writing here shoot. It doesn't mean only stem. It means each and every part of the shoot. That means in branches, you will see the extreme end of the branch. You can see, you can imagine about the leaves, new buds, new flowers. So at the tip of root and shoot. Now lateral, as the word represents, lateral means side by side. So these are found at the peripheral part of parts of shoot and root. Peripheral, that means I think you know the word bark outside. Okay. Now intercalary, where they are found? They are found below and above the nodes. Below and above the nodes, or sometimes you can say in girth of root and shoot. No, in girth of shoot, not root, because nodes are the characteristic features of shoot. Occurrence. Now it is clear. At the tip of root and shoot, apical are found, lateral, peripheral part of the shoot, intercalary, below and above the nodes. Here you can learn that at the base of leaves, this intercalary are reported in pinus. Below the leaves or below the nodes, it is reported in mint. Pudina, we are writing Pudina, I think you know. Now above the notes, it is reported in grasses. Now what are their main functions? Main functions, you must remember, apical has main functions in the growth in sense of length. So we can write here, increase the length. It increases the length of plant part. What it does, it increases the diameter. That means I told you that circumference in the peripheral area these are found. So it increases the diameter of shoot and root. One very important thing is it helps in secondary growth. It helps in secondary growth. Secondary growth, you may confuse, so let it be clear. Primary growth and secondary growth. Primary growth are the growth which has taken first of all. That means when the cell get birth, then it get elongated. After some time, they may either differentiate it to any particular cell or may cell division. If they divided, again the life cycle is set. But when it gets differentiated, it is up to differentiation, it is primary. But sometimes it happens that due to any injury, any cut in the plant sections, certain parts will start to divide again, which is already differentiated once. So if the division starts in the part which are already differentiated earlier, then it is called secondary growth. You will, here I will teach you that the cambium, cambium, corcocambium, phellim, phelogen, pheloderm, these all are formed from the secondary growth. Now intercalary, what is its a function? Its a function is to provide the mechanical strength. To provide the mechanical strength. Now be careful that for a class 9 student, these questions are asked in different ways. Which tissues are found in girth? Which tissues are actually mainly providing mechanical strength? Which tissues are found in the peripheral area, which helps in the secondary growth? Many objective questions can be asked. But in class 9, only 3 points you have to take care. One is the structure, what I taught previously. Then where they found, that is occurrence, and then what are their functions. But now I am going to explain you something which is beyond class 9. So for a class 9 student, the video is over. But for class 11 student, please be continued. Now apical. There was one scientist named Schim, Schimtt. He gave one theory. That theory was tunica corpus theory. Tunica corpus theory was given in 1924. What the name of that theory was? Tunica corpus. Tunica corpus theory. You must remember the name of the scientist and the theory. What is the main statement of this theory? Everything is not possible to write on the board. Tunica and corpus. He suggested that from the apical meristem, the outer layer should be called with tunica, and the second layer or the inner layer of the apical meristematic tissue should be called corpus. So tunica and corpus, this will give rise to the different parts he suggested, but tunica would be given the first name of the outer layer and corpus the name given to the inner layer. The second theory was histogen theory. Histogen theory was given by Hanstein. Given by Hanstein in 1824 or 1874. What the histogen theory told? Hanstein, who proposed the histogen theory, he told that three structures can be formed from the outer layer or from the apical meristematic tissue. What are the three layers? The three layers are, first was dermatogen. First, dermatogen, you can say outer layer of epidermis, were named as dermatogen. Today, the name changed. It is also called protoderm. It was the first layer suggested by histogen theory, outer layer, and it will later form epidermis. एपिडर्मिस लेटर फॉर्म, दैट मीन्स बाद में ये बनेगा एपिडर्मिस, डर्मेटोजेन ही आगे एपिडर्मिस बनाएगा. सेकंड वाज पेरिब्लेम. Periblem will later form the cortex part of the root and shoot. Now the third was plerome. It will later form steel and pith. So actually the theories were given to show that which part is formed by which layer of apical meristematic tissue. Schimtt told that first layer is tunica and other layer is corpus. Tunica will form the epidermis and corpus will form the inner part. Now histogen theory suggested that first outer layer will be dermatogen. Today we know the name as protoderm. Will later form epidermis. Periblem is the middle layer which will form later cortex, and plerome is the internal layer which will form steel and teeth. Now lateral meristematic tissue. Here it is important for class 11. Lateral meristematic tissue, I taught you previously in this video that lateral meristematic tissues are actually helping in the secondary growth. So two types of secondary growth can be done or can take place in lateral meristematic tissue. Secondary growth. First is vascular cambium and other is protective cambium. Vascular cambium and protective cambium. What is vascular cambium? Vascular cambium are the cambium which are formed nearby the xylem and phloem, that is vascular bundle. Protective cambium are the cambium formed in the outer layer. So it protects the plant organ and it increases the function of xylem and phloem. So vascular cambium is popularly known as phloem. Phloem, or sometimes we are saying cork cambium. It will later form springwood, autumnwood, heartwood and sapwood. You must remember that wood, the word wood, generally we are knowing the word as lakdi in Hindi, but wood is actually xylem or phloem here with the cambiums. Spring wood, why it is called spring? During the spring season, the cambium is growing fastly in this plant. It is light in color, and in this type of cambium, wider vessels are there. Wider vessels and light color is the characteristic property of a spring wood. Wider vessel, vessel is a component of, or we can say element of xylem tissue. Xylem is made up of four elements: tracheids, vessels, xylem parenchyma, xylem sclerenchyma. So it is light in color, and the vessels, particularly vessels, are having wider area or wider lumen. Autumn wood, it is dark and narrow vessels are there. So autumn wood can be characterized by its color as well as the lumen of the vessels. Now sapwood, here it is again in light color and it is in dark color, and here it is non-conducting. Non-conducting, that means this type of modification of xylem will not help in the conduction of water and minerals. You know that xylem has main function to conduct, to transport water plus mineral to after absorbing from the root to different parts of the plant. But here heartwood will not conduct water, but reverse, sapwood will conduct water. It is a conducting tissue. Light and dark color is also the property. Now here one more thing you can say, here deposition of organic compounds are not found. Without deposition of organic compound, and here deposition found. Deposition of organic compound. So these are the vascular cambium. Now protective cambium, what can you learn? Protective cambium is formed, you will learn them as phloem. Phloem is actually cork cells. It is cork cambium. It is also cambium, but it is found in the outer area, just below the bark. Bark is not a biological term. It is mistakenly we are using for the outer skin of the stem or plant part. But bark should not be used biologically. Phloem is the cork cell. It is found just beneath the epidermis. These all are the parts of it. Is protected, no? It is the part of epidermis, outer skin. So phloem, we can say cork cell, and second is phloderm. Phloderm. What is the difference between phloem and phloem? It is dead and suberized. Dead and suberized. That means they are dead, and suberized means extra deposition of suberin are found in the phloem or the cork cell. But oppositively, it is living and parenchymatous. Living and parenchymatous. So these are the properties of lateral meristematic tissue. What these words are, phloem and cork cambium are found in nearby xylem, phloem, inside also, between xylem and phloem, if they are found, it is called intrafascicular cambium, and if they are found beside the xylem, two xylem tissues are there, and in between, if the cambium are found, these are called interfascicular cambiums. Now, protective phloem, phloem. What for the intercalary? For intercalary, they are only providing the mechanical support and they will become immediately dead. So now there will no any further classification. These all are for class 11, not for class 9. So 9 student, I clearly demarcated by giving a statement that class 9 student will study up to that, and if you wanted to study more, then you can understand these all things. It will be helpful in your biology in class 11. Thank you. Best of luck.